All right, so today you're going to take some notes on the packet. Once you're done with taking the notes on the packet, you can show them to the sub. Sub will give you your homework assignment, and hopefully you can get both of those done today during class. So today we're going to finish up talking about functions. You have a quiz on functions on Wednesday. On Tuesday, we will talk about slope-intercept form some more. So here we go. All right, so a function is just a fancy way to write an equation. Instead of writing something in the form y equals mx plus b, function notation says instead of y, just to write f of x equals mx plus b. And that could work for any equation where it's y. So if it was y equals 2x plus 1, we could say f of x equals 2x plus 1. And that's how you read that, f of x. F obviously stands for function, but you could also use other letters. It says here G and H are options. But pretty much any letter you could use to name a function. Okay, so here is the name of the function. Whatever variable you're going to be substituting in, aka the input. And then on the other side, it's whatever is happening to the input. So in this case, it would be 2 times whatever whatever number you're putting in for x. This is just another slide of examples of, instead of using a y, we're going to use function notation. So f of x, g of x, h of x. It's all essentially the same thing. It's just a different way to write them. I want to note that on your slides, I forgot to say state the domain and range, but we're going to state the domain and range on all problems in our notes today. And the sub will be checking to make sure that you've done that so that you have good practice for doing it on your homework. You are expected to state the domain and range after each problem on your homework. Okay, so f of x, well, I got these 3 numbers that I'm going to put in for x. So instead of saying y equals, typically we would say y equals 15 times negative 2 plus 4. Really, the only thing that's going to be different is we're going to use f of x. And to be a little bit more specific, well, what are we putting in for x? Well, we're putting in negative 2. So f of negative 2 equals negative 30 plus 4, which equals negative 26. It's just substitution, ladies and gentlemen. Nothing really that mind-blowing. Okay, so now we want to find f of positive 2. So we're going to take 15, we're going to put in 2 this time for x, and we're going to add 4. So 30 plus 4 equals 34. So f of 2 equals 34. F of negative 2 equals negative 26. And last one, we're going to do f of 10. F of 10 would be 15 times 10 plus 4. 150 plus 4. And f of 10 equals 154. Next slide. All right, so we're going to do f of negative 3. We're going to do f of 0 and f of 1. All that means is we're going to put negative 3, 0, and 1 in for x. So let's put negative 3 in for x. Let's put 0 in for x. Let's put 1 in for x. And then compute. 21 minus 5 is 16. So f of negative 3 is 16. F of 1 is negative 7 minus 5, which equals negative 12. And f of 0 equals negative 5. Next. Oops. I used the wrong letter the whole time. Some of you are probably like, what are you doing, Mr. Korth? Some of you didn't notice. So the function's name was p last time. And so I should have said p of negative 3, p of 1, p of 0. Learn from my mistakes. So we've got m of x, so that just means we're going to put these numbers in for x. It doesn't change anything that we do. M of 1, m of 10, m of 2. So negative 4.4 times 1 is negative 4.4. So m of 1 is negative 4.4. Negative 4.4 times 10. So m of 10 equals negative 44. Check, check. Negative 4.4 times 2 equals negative 8.8. So m of 2 is negative 8.8. Next slide. H of x this time. So we're going to take h of x. H of 1 equals 4.2 times 1 minus 3. H of 0 equals 4.2 times 0 minus 3. H of 10 equals 4.2 times 10 minus 3. So 4.2 minus 3 is 1.2. H of 10 equals 42 minus 3. So H of 10 equals 39. And H of 0 equals negative 3. So the domain and range, remember your domain is your x values, 1, 0, and 10. Your range is your new y values that we just found. So that's going to be your three answers, 1.2, negative 3, and 39. And you may be thinking, Mr. Korth, you didn't do that on the other slides. You're right, I didn't. I forgot. So your domain here should be 1, 10, and 2. Your range here should be negative 4.4, negative 8.8, and negative 44. Trying to get ready to forgetting to do things. Domain here is negative 2, 2, and 10. Your range is negative 26, 34, 154. Okay. Your domain here is negative 3, 0, and 1. Your range here is negative 12, negative 5, and 16. All right. 3 more. Find f of 1, f of 5, f of 30. 2 times 1 plus 2. 2 plus 2 is 4. F of 1 equals 4. 2 times 30 plus 2. 60 plus 2 is 62. F of 30 is 62. All it's saying is that when you put 1 in, you get 4. When you put 30 in, you get 62. When you put 5 in for x, you get 12. And it's more important that you can get the answers as to whether or not you write the final answer with that notation. Your domain here is 1, 5, 30. Your range is 4, 12, 62. Okay, 2 more. G of 5, G of negative 5, G of 0. 3 times 5 minus 7, 3 times 0 minus 7, 3 times negative 5 minus 7. 15 minus 7 is 8. G of 0 is negative 7. Negative 15 minus 7 is negative 22. G of 2 equals 3x minus 7. G of 8 equals 3x. 3 times 8 minus 7. And G of 9 equals 3 times 9 minus 7. 6 minus 7. Domain. 5, negative 5, 0. Range. 8, negative 7, negative 22. I got you confused enough yet? Good. Okay. So that's negative 1. G of 2 is negative 1. 27 minus 7 is 20. G of 9 equals 20. 24 minus 7 is 17. G of 8 equals 17. Domain 289. Range negative 1, 20, and 17. Some of them I forgot to put them in smallest to largest, but as long as you have all the numbers in the set, we're good. So show your completed notes